Your Selenium tests passed locally. They passed in staging, you merged the PR, and then CI went red. Not because anything is actually broken, but because 3 tests decided today was the day they would stop cooperating. Flaky Selenium tests cost teams up to 70% of their testing budget in maintenance alone. That is not testing. That is babysitting. Today I am going to show you how to use Claude as a real-time pair programmer to hunt down race conditions, refactor brittle assertions, and turn your Flaky Selenium suite into something that actually stays green. Let me hit you with the numbers because this is worse than most people realize. TestDino analyzed over 300 test suites and found that Selenium has a 72% test stability rate. That means nearly 1 in 3 test runs produces an unreliable result. For comparison, Playwright sits at 92%. That is a 20-point gap. Practitests found that 45% of teams report frequent test breakages due to UI changes. Engineers spend 40 to 50% of their E2E testing effort fixing broken tests that are not even catching real bugs. So why is Selenium so flaky? It is not your code, it is architectural. Selenium uses HTTP-based WebDriver commands to communicate with the browser. Every action is a round trip over HTTP. That latency creates timing windows where the DOM can change between when Selenium checks for an element and when it actually acts on it. That is where your stale element reference exception comes from. A 500 test suite takes 60 to 90 minutes on Selenium and 30 to 40 minutes on Playwright. Playwright avoids this by using a direct WebSocket connection through the DevTools protocol. No HTTP middleman. Its built-in auto-wait mechanism reduces flaky failures by 60%. Here is the human cost nobody talks about. The developer merges a PR. Tests go red. The developer says those tests are flaky, not my fault. The QA engineer says those tests were green until your commit. And then everyone spends 2 hours in a Slack thread arguing about who broke what, while production quietly catches fire in the background. This cycle repeats every sprint. It erodes trust between the 2 groups that need to collaborate most closely. Both sides are usually partially right. The tests are fragile and the commit did expose a real timing issue, but without proper diagnostic tools, nobody can prove what actually happened. This is where AI-driven pair programming changes the game. Most people use AI to generate test code. That is fine, but that is the least interesting application. The real power is using Claude as a debugging partner. You feed it your actual failure logs, DOM snapshots, and race condition data, and it diagnoses problems that would take you hours to trace manually. Step 3, Claude identifies the pattern. With proper context, Claude can trace the exact causal chain. Here is the workflow. Step 1, capture the full failure context. Do not just copy the stack trace. Grab the DOM snapshot at the exact point of failure, the network requests in flight, the console errors, and the timing data. The more context you feed Claude, the better the diagnosis. Step 2, ask Claude a specific question. Do not say my test is flaky, fix it. Instead say this test fails intermittently on the checkout button click. Here is the DOM snapshot at failure time, the timing between page load and click attempt, and the network log showing an async call that completes after the click, what is causing the race condition. Step 4, refactor with resilient patterns. Instead of thread.sleep as a band-aid, Claude suggests explicit wait conditions tied to actual application state. For example, it might identify that a React state update triggers a re-render of your checkout button 200 milliseconds after the page appears loaded. Your Selenium script sees the button, checks is displayed, which returns true, but by the time the click executes, the element has been replaced. The click lands on a stale reference and the test fails. A human might spend 2 hours tracing that. Claude spots it in seconds. When the QA engineer comes back with a Claude-assisted analysis showing exactly which commit introduced the race condition, wait for the network call to complete, wait for the re-render to settle, then click. Show text overlay. Thread sleep is not a strategy. It is a prayer. With DOM evidence, network timing proof, and a suggested fix ready to go, that changes the entire conversation. Your test clicks a button, but nothing happens. The click is landing on an invisible overlay, a loading spinner, or a transparent element, with a higher Z index sitting on top of your actual target. Claude analyzes the DOM layer stack and finds the interfering element immediately. But there is a background API call still in flight that is about to re-render half the page. Your test acts on elements that are about to be replaced. Claude reads the network log, spots the pending request your test did not wait for, and suggests a proper wait condition. Your reference points to something that no longer exists. Claude identifies the re-render trigger. Pattern 4, the timing lottery. Tests pass on your fast machine and fail in CI because element timing varies by 100 to 500 milliseconds, depending on compute resources. Claude replaces implicit waits with resource-independent explicit conditions. Pattern 5, the iframe trap. Your element lives inside a dynamically loaded iframe, and your test does not switch context before interacting. Claude finds the iframe boundary. Every one of these takes 30 minutes to 2 hours to debug manually. With Claude, diagnosis takes under a minute. Selenium market share dropped from 40% to 22% in some regions. Playwright weekly NPM downloads hit 13.5 million in 2026, surpassing Cypress. Playwright runs tests 42% faster and produces 67% fewer flaky failures. A 500 test suite takes 60 to 90 minutes on Selenium and 30 to 40 minutes on Playwright, while you plan a gradual migration. Claude helps with both. It debugs your current flaky tests, and it can help you plan a phased migration. Whether you are on Selenium, Playwright, or Cypress, the skill of using AI as a systematic debugging partner transfers everywhere. You are not learning a Selenium trick. You are building a career skill. If a test fails more than 10% of the time, it is not a test, it is a coin flip. Flag it, fix it, or delete it. Number 2, create a debugging context template. Standardize how your team captures failure data. DOM snapshot, network log, console errors, timing data. Make it a team habit. When you show leadership that 70% of the testing budget goes to keeping old tests alive, you get resources to fix it. Number 3, track your maintenance costs. Measure how many hours per sprint go to test maintenance versus new tests. Number 4, start a migration pilot. Identify your most flaky, most expensive test suites and run a small-scale Playwright pilot. Track stability, speed, and maintenance hours before and after. Let the data make the case. Do not argue opinions. Present evidence. Green builds are not luck. They are methodology. If you found this valuable, hit that like button, subscribe, and drop a comment. What is the worst flaky test you have ever dealt with? Give me your horror stories. Until next time, stay sharp, stay curious, and keep those builds green. Green builds are not luck, they are methodology.